Welcome to Process Analytics. I am Dr. James Rowe from the College of Business at Rowan University. We are laying foundational knowledge about process analytics. So far, we have covered define and measure phases. In define phase, we learned the importance of taking the time to define the problem, customers, and the process. In measure phase, we learned process metrics, value stream mapping, and process capability. We are now on the third module of the course, Analyze phase. After defining the process and collecting the data, we need to analyze the process. There could be many methods that can be utilized for analysis. In this module, we focus on regression and hypothesis testing. Module 3 pertains to Analyze phase. You have taken the efforts to define the process and measure the process using various metrics. Now it comes down to how to analyze the data and metrics. Picking up the right method and conducting the right analysis are keys to finding insights. In this phase, simple linear regression and multiple linear regression will be covered first, and then we will learn various hypothesis testing. Let us first define analyze phase. It is an examination of processes, facts, and data to gain an understanding of why problems occur and where opportunities for improvement exist. The first topic of this module is analyzing relationships. Let's take a look at correlation analysis before understanding regression analysis. Correlation analysis is defined as the study of the relationship between variables. It is also defined as a group of techniques to measure the association between two variables. It helps us to see the relationship between the two variables by visualizing it. Scatter diagram is expedient for us to understand the relationship. Does one factor affect another factor? Are they dependent to each other? We can determine that by examining the correlation. Dependent variable is the variable being predicted or estimated. It's usually affected by independent variable. The independent variable or a factor provides the basis for estimation. It is a predictor variable. Here is an example of correlation between number of sales calls and number of copiers sold. We assume that the more calls a salesperson makes, the more sales will be made. Is it true? To examine that, we look at the scatter diagram. Scatter diagram tells us that there might be positive correlation between them. However, we are unsure how closely they are related to each other. We want to quantitatively understand the relationship. That's where correlation comes in. Correlation is called the coefficient of correlation, R. It ranges from -1 to 1. The closer to 1, the more linear the relationship it is. Say if it is 1, there is perfect positive one-to-one relationship. If it is, say, negative zero point 0.1, it has a low linear relationship. Note that zero correlation does not necessarily mean zero correlation relationship. Even though it is zero, there could be a curvilinear relationship between the two variables. Zero simply means the absence of linear relationship between the two variables. The coefficient of determination is the proportion of the total variation in the dependent variable y that is explained or accounted for by the variation in the independent variable. It is the square of the coefficient of correlation. R square ranges from 0 to 1. There is no negative R square because it is squared. The downside of that is that it is difficult to tell whether the linear relationship is positive or negative. The formula to calculate R square involves many steps as shown in this table. You can find the mean of the sample and subtract it from each sample value. To find the correlation, you will need to multiply them together. Finally, you put the result into formula at the bottom. Coefficient correlation can be derived from correlation. In this case, correlation was 0.759. Once you find the correlation, it is easy to get R squared because you just need to square it. Then you have 0.576 in this case. And you convert it to percent, then it becomes 57.6%. What does it mean that the coefficient of determination is 57.6%? It means 57.6% of the variation in the number of copiers sold is explained or accounted for by the variation in the number of sales calls. Let's go over a few questions. First question. A study was conducted on the relationship between the speed of different cars and their gasoline mileage. The correlation coefficient was found to be 0.35. Later, it was discovered that there was a defect in the speedometers and they had all been set 5 miles per hour too fast. The correlation coefficient was computed using the corrected scores. Its new value will be, what will that be? The answer is B, 0.35. Because it's regularly subtracting 5 miles, it does not really affect the correlation itself. Second question. Which of the following statement concerning the coefficient of simple linear correlation is true? A, R correlation is 0, represent the absence of relationship. This is not right because I said there could be curvilinear relationship. B, the relationship between the two variables could be nonlinear. Yes, this is correct. C, 0.76 has the same predictive power as negative 0.76. Um, predictive power is a separate thing. D, correlation is 2, and it represents a perfect relationship. If it is 1, that means it's a perfect relationship. There's no such thing as 2 in correlation. So the answer is B. Third question. A regression analysis yielded a total sum of squared errors of 1000 and total sum of squares equal to 1600. What is the correlation coefficient? A, cannot be determined from the given information. B, from 0.375 to negative 0.375. The answer, if you, in this case, it involves some calculations. Remember that R square is SST minus SSE over SST, and this is given here as 1600 is total sum of squares, and minus sum of squares of errors is 1000. So 1600 minus 1000 is 600, and you divide it by the total sum of squares, which is 1600. Therefore, 600 divided by 1600 is 0.375. So the answer for R square is 0.375. Now, correlation is you have to take the square off of that, right? So if you do that, then R is going to be square root of 0.375, and that is plus minus 0.6123. So the answer is C.